today's lecture we are going to be talking about product and process design. If you recall, in the last lecture we had talked about determining the optimal product mix. So invariably a company would have a number of products to produce, and once the decision on the number of products and their designs is fixed, one of the crucial decisions that the company has to take is how to manufacture these products. That means what kind of processes to adopt. So this particular phase is often known as process planning, and in today's lecture we are going to be talking about the interactions between product and process design essentially. In this diagram we have tried to look at or summarize the major activities of product design, process planning and manufacture, which generally proceed in this particular sequence. So let us recall what exactly product design is, what are the inputs and outputs to product design, and subsequently how process planning takes place, and finally this particular cycle ends with this aspect of manufacture. Product design requires essentially the design specifications and the basic requirement that the customer wants for the particular product, and we have already seen in previous lectures that there are various methods available for gathering customer opinion, like QFD, and talking about developing the design specifications from the customer. From this design specifications and requirement, ultimately we develop what is called a functional design. A functional design of the product is one which focuses primarily on the function that the product performs, and then we talk about the production design, where aspects of ease of production are taken care of, and ultimately as a consequence of this entire exercise the output of the product design division is to get drawings and specifications of what to make. So that's what it generally is. Notice of course that in all these decisions one very crucial decision is the decision on customer demand. So how much to make, either in terms of the forecast or firm orders, is generally available, and this governs to a very large extent on aspects like what should be the production design, what should be the, how should products be manufactured so that this quantity is taken care of, and so on. So this is a very important auxiliary input to the whole process here. Once the product design is made, which is in the form of design specifications, drawings and specifications of what to make, the next general phase is what we call process planning. And in process planning we are generally concerned with, number one, an activity known as product analysis, which is actually summarized by the development of assembly charts and flow charts. We'll just see, for instance, what we mean by assembly charts and flow charts, but let's first look at the entire flow of information. And the assembly and flow charts will actually specify the various components which go into making the complete product design. Then about each component you have to take the decision on whether to make it or buy it. Many of the components are standard components, so you prefer to buy them. Other components you might have to make. So this decision on make and buy for the large number of components which have to make the product, this has to be taken. And for components for which you take the make decision, for that particular decision you have to decide on the process sequence, not only the process sequence but which processes to adopt. Quite often there is a selection from alternative processes. So this decision becomes important at this stage, and once you have finalized or taken these decisions, you summarize these decisions in the form of documents which are known as route sheets and operation sheets. A route sheet is a document which specifies the route to be taken by a particular component as it flows through the factory. So it says that it would first go on maybe this machine, it would perform such and such operations. So details of the operations are available in the operation sheets, and the route sheet specifies exactly the route that you have to take. It's very much like an itinerary. When you have to go on a long trip, you know I'm going from city 1 to city 2 to city 3, and then what you are exactly doing in city 1, city 2, city 3 is actually the operation sheet. So this is how these processes are typically documented, and they give the specifications of how to manufacture. Now another important thing in these route sheets and operation sheets is a specification of the workplace and tools design. That means what kind of tools are going to be used, what is the specific workplace, and so on. So along with the operation sheet, this information is generally available. So these are the route sheets which govern the manufacturing process. When it comes to manufacturing, you may have to modify some of the process plans due to layout, quality preference, and machine availability constraints. So those are things that you might have to do while you are doing the manufacturing. So this basically summarizes the entire sequence of operations, starting from the development of the product design to process planning to subsequently manufacture. Now just to clarify some of the major documents which are involved in this exercise, we can see, for instance, here, let's take a look at some of the documents. For instance, we were talking here at this stage about assembly charts and flow charts. Let's first see what is an assembly chart. For instance, if a component like a plug assembly drawing is available, and this is what has to be, what is the product which we have to make, what would normally happen is that the various components which go to make the entire assembly would be shown here in an assembly chart or a goes into chart. For instance, the plug housing is here, and then on the plug housing, the first thing that is done is the air outlet and the flange air connection. It is sub-assembled, and then this sub-assembly goes on to the plug housing, and then on this completed sub-assembly, you put up the lock ring, the spacer, the two rivets, the spring indent, etc. All these are first assembled in the form of a sub-assembly 2, and then this sub-assembly goes to the sub-assembly to this particular situation here, and so on. So a diagram like this gives you a bird's eye view of how various components are going to fit together in generating the final product. So this is what we mean by an assembly chart, and when we are talking about the beginning of process planning here, we are talking about assembly charts. So this is exactly what an assembly chart would look like. Then this is what a typical operation and a route sheet for the same product looks like. What it describes is, for instance, that it's a plug assembly that we are talking about. Now the plug assembly is one component of this whole thing. So this is the plug assembly, let us say the first component which goes into the assembly chart. This would describe the various operations that have to be performed on the plug assembly. Say the first operation is drill hole 0.32, the tolerances are given. This would be done in this department called drill. This is the machine which would be used for doing this. The setup time required for this is 1.5 hours, and the rate in pieces per hour is 254. The tools and fixtures are also specified here. So the details here describe the operations, and this is otherwise a route sheet because it describes how this particular component, the plug assembly, will keep moving from one stage to another, and what exactly will happen to that particular component. So if, for instance, as youngsters you go to a new factory and are interested in finding out what happens and what is the sequence of manufacture, you should be asking for the assembly chart and the operation and route sheets, which will describe exactly what information you typically require about the component. This particular diagram is called a flow process chart. In a flow process chart, essentially we are using the standard industrial engineering symbols of circle for operation, transportation, storage or delay, and an inspection. And what is being said here is that this particular chart describes how the plug housing from the plug assembly, that is that particular component, will move and what are the timings. So it shows actually that it moves, material is received from the supplier and it is in storage, and then the time required to inspect it is given here, and then from inspection it moves to the finish department. From the finish department you apply corrosive treatment, then it moves to raw material store. So it describes here whether it is an inspection or a movement or an operation as per this situation, and ultimately it comes out and keeps going like this. Even the distance moved can be put on this chart, so that this chart would be very valuable for identifying the material handling movement for individual parts, so that subsequently if you are trying to suggest an improvement in the process, you can compare one process with another in terms of the total material handling movement. So these are some of the basic charts and other kinds of information which is utilized for consolidating information about the product and the process and how exactly the product flows through the process. Let us now talk about the product in little greater detail. Every product has a product life cycle, and typically if you look at the stages of the product life cycle, we can identify 4 different stages of the product life cycle. The first stage is the startup stage. When the product is introduced, typically the sales volume tend to grow at a smaller rate, so that the slope of this line is generally small, and thereafter comes a stage when the product picks up in popularity, where there is a period of rapid growth of the product. So the slope here tends to grow up suddenly, and then after the product has grown to a significant extent comes the stage of maturity, where product volumes tend to stabilize. So that is the stage of maturity of the product. And finally you have the stage, the product can take 2 possibilities, 2 possible roads. It can either decline or it can grow at a steady rate in the form of what is called a commodity. It means it has become the product has become so popular and is like a commodity, is like a household commodity which is needed every day from period to period, right. So for instance, a product like soap, for instance, which you use of a particular brand might have become a commodity and therefore is now at this stage of the life cycle. Now when we talk about the product life cycle, we have different behavior of the product at different stages, and we can actually look at the characteristics of the product at different stages. We had identified these 4 stages 1, 2, 3, 4 as startup, rapid growth, maturity, and decline or commodity, as the case may be. Now if we look at these 4 stages 1, 2, 3, 4 in that order and try to see exactly what happens to the product at different stages, we will study for instance the behavior of a typical product with regard to product variety, product volume, industry structure, and the form of competition. That means how is for instance, it is generally felt that when a product is introduced, there is a great variety of manufacturers who come up on the scene and they try to manufacture, give you a lot of variety in the beginning. However, as the product tends to stabilize and there is a period of rapid growth, what happens is that there is increasing standardization, and this process of increasing standardization, ultimately at the stage of maturity there is an emergence of a dominant design, and all other designs are generally washed off from the scene. And in the fourth stage there is a high degree of standardization, and there is a commodity characteristic, which you meant that it becomes a household commodity. So there is a high degree of standardization at this stage and so on. So this is as far as product. So product variety generally is high, it tends to fall, and finally you settle. Most companies would settle for one dominant design, and the product variety as far as that is concerned would tend to go down. Look at product volumes. As far as the product volume is concerned, it's low in the beginning because there is a initial reticence on the part of the customers to adopt new products, and therefore there is a low product volume. It generally tends to increase at the second stage. It becomes high during the stage of maturity and remains high during the stage of high. Let's see what is the industry structure. Industry structure means look at the entire set of people who are manufacturing that particular product. Normally when the product is introduced, what happens is that a large number of small competitors come on the scene to manufacture the product. What happens as the product sales grow, there is a fallout and a consolidation. So the number of competitors who remain gets much reduced, and moreover there is consolidation among the competitors themselves, so that they have larger companies. At this stage only a few large companies remain who are manufacturing this product, and out of these few large companies, in the last stage only the few survivors will be there who would. So you see the impact of this particular product on the industry structure in terms of how competitors grow, fall, and subsequently only there are a few survivors who actually manage the show. If you take the case of soft drinks, for instance, Campa-Cola and Pepsi, these are the few large companies who have survived, and all other small manufacturers in the Indian context have actually been either fallout or consolidated or bought out by these various companies. Let's see the form of competition. What's going to happen to the competition? Initially the competition is based on product characteristics, because when you buy a new product you are very careful to choose what or find out what the product characteristics are. So competition among products is based primarily on product characteristics. As sales volume increases, the competition generally is on the basis of quality and availability. That's the main thing. At the third stage it just becomes on price and dependability, right? You should be able to get a suitable price, and the supplies should be dependable in that sense. And generally at the last stage the form of competition is governed mainly by price and not by other things, because it's like saying that as you go along you have to cross a number of barriers, but the final barrier at the fourth stage is the price. So this I think gives you an idea of how different products behave on different fronts during their various life cycles. Let us now talk about some of these what we understand by process design or process technology. Basically when you are talking about manufacturing process technology, what we mean in very simple terms is the equipment, the people, and the systems that constitutes process technology, which are used to produce a firm's products and services. So equipment, people, and systems, all these three things are important, and there could be growth and development in all the three. But let us now try to see what would happen to the processes when one comes to talking about process technology. The key decisions that are there in selecting an appropriate process are, we can talk about organizing process flows. This is very important. How your materials will tend to flow through the plant, through various machines, and what kind of process flows do you design. Normally you would like to have as smooth a flow of materials through the plant as possible, but generally this does not happen in all situations. Depending upon the type of process you adopt, typically you might adopt a process which is a project. Now typically a project would be relevant only when you are making something only once and you are probably involved in setting up a new process or designing a new building or introducing a new product or something of that type, where the task would be essentially to identify what all requires to be done and then develop the relationships between those tasks and then make a schedule by using a typical project network which will tell you when to do what, right. That is the kind of thing that happens here. So this is a very personalized kind of treatment that you are given a project, because the kind of problem that you are handling is not essentially repetitive. If you take a job shop, what would happen in a job shop? A job shop again is something where you have a number of machines, and these machines are generally general purpose machines that you have. I buy a lathe, I buy a milling machine, I buy a grinder, and I set up a job shop, and then I look for jobs to make whatever I can with these three machines, and I can make a variety of components, a variety of products. So what happens here is you cater to a large variety with standardized machines, but because of the nature of your variety, what happens is that the flows get pretty complicated. Each product or each project or each job will go through the job shop depending upon its own requirements, and therefore it would create a lot of confusion as far as movement is concerned. This confusion is to some extent reduced in batch production, because you are organizing your flows in terms of batches of products, and you are also trying to get the advantages of a common setup for various parts. Assembly line is obviously, as you know, something that you use when you want to manufacture a single product without changes in design, and you want to make it in relatively large quantities. So you can set up an assembly line, and that is the feature of this will be that you will have relatively smooth flow lines. And continuous flow is generally different from assembly line flow, isn't it? Assembly line flow is what we often call discrete manufacture. When you are manufacturing cars, for instance, you get one car and then the next car and then the next car, so everything comes out in digitized units. Whereas continuous flow is something, I don't think you can imagine cars coming out continuously, you know, like coming out of a tap of water. First 5 millimeters generate maybe the first car or whatever it is. That doesn't happen. So continuous flow refers primarily to chemical plants, refineries and other situations where the product, the output is coming out continuously, and normally in such cases also the flows are pretty smooth, and they can be controlled by controlling the environmental parameters and the other control parameters in the whole process. So these are some of the key decisions that you have to take as to how you are going to manufacture. You have choices available, and this is what we are looking at. We can be talking about choosing the appropriate product process mix, right. That means we can say, for instance, that you might decide that you have 5 products to make, 5 car models, let us say. If you consider the components, you might have something like 20,000 components to make. Out of these 20,000 components, you might have decided that 10,000 of these components you will buy from outside. So you are left with 10,000 components to make, and then these 10,000 components, for each component you have to decide as to what kind of a process it will go through. So within the context of the factory, you might have a combination of a job shop, a batch production, assembly line, and even continuous flow, all taking place together, because each of these is catering to different components, say the 10,000 components which you are now going to make. And then you have to talk about adapting the process to meet strategic requirements. What do we mean by this? Strategic requirements could be there. What kind of strategic requirements are we talking about when we are talking about adjustment of process flows to meet strategic requirements? You see, product design and redesign could be a strategic requirement, right? What may happen is that you have a competitor who has introduced certain features in the model of his car. You might want to introduce more features or something. Now what we are trying to say here is that your processes should be flexible enough to be able to accommodate these changes in the design and adapting the process to meet these strategic requirements which are necessary. This is again another important aspect. And then another key decision here is evaluating automation and high technology processes, because the degree of automation and high technology, which could vary from product to product, but you have basically it's a decision on what is the level of automation that you should have and how exactly you should use this for planning your processes within the factory. So this gives us a broad idea of the kinds of processes which are involved and the decisions that have to be taken to manage these various processes. Let's now look at the interaction between the product structure, which is during the 4 stages of the life of the product cycle, right? We are talking about the product structure on this axis, and we are talking about the corresponding processes 1, 2, 3, 4, which are characterized by these features. For instance, the first kind of process might be a jumbled flow, which is what we call a job shop. The second kind of process might be a disconnected line flow, which we call batch production. The third kind of process might be a connected line flow, which is essentially an assembly line. And the fourth kind of process might be a continuous flow, which is talking about these. Now, this particular matrix, similarly on this side we have the 4 stages of the product structure as it goes through its life cycle. What happens is, what are the typical characteristics here? We have summarized them here. At the first stage we have low volume, low degree of standardization, and one of a kind of product which we are trying to make. Then we have multiple products, low volume in the second stage. Here we have few major products but relatively low volumes. Relatively low means, of course, volumes are higher than this, volumes are grown, but typically. And at the fourth stage, high volume, high standardization commodity products in that sense. So if you see that for different types of products in the life cycle of a product, you need different types of processes, right? And typically the processes tend to move on this diagonal. What happens is that for this kind of product structure, low volume, low standardization, you typically require a job shop. So a typical example is a commercial printer, which operates generally as a job shop. The typical printing process that we talk about, it operates as a job shop, and you have this particular scene. Then maybe we make a transition to some kind of heavy equipment, where for heavy equipment might be you are trying to manufacture, let's say, lathes, and you are trying to manufacture the kind of activity that maybe HMT is engaged in, where it makes machines on order for different components. So essentially when you are talking about heavy equipment,
it could be a disconnect line flow. So, there is a batch production, they aggregate the orders of different kinds, and we are talking about multiple products with variations of the machines, and you come to this particular feature here. Then this product could then graduate to a situation where we have something like an automobile assembly. An automobile assembly is, we have few major products, and this is a connected line flow in the form of an assembly line, and you have come here. And finally, we could give an example of continuous flow, which could be sugar production or a refinery, where you are talking about the whole product as a stabilized commodity, and this stabilized commodity, like sugar, is a household item, right? Everybody consumes it, and similarly products from the refinery, you have the operation taking place here. So, this matrix is called the product process matrix, which shows that there is an intimate relationship between the kind of product you want to make and what stage it is, and the kind of processes you have to adopt. And you typically find that this region, there is nothing there, it is a void. Similarly, this region is a void, and normally all companies tend to grow from here to here to here to here, and that is how typically the product process matrix actually identifies how the evolution in the processes takes place as companies tend to mature. We were talking so far about the product life cycle. If we now talk about the process life cycle, the process life cycle essentially, as we had seen from the product process matrix, would have these 4 phases. Initially, you tend to deal with the product during the startup phase of the product as a job shop, and then during the rapid growth stage, typically you graduate to a batch production system. During the stage of maturity, you graduate to an assembly line where you require, and then once it becomes a commodity, then you have a continuous flow. And the manufacturing costs per unit typically tend to go down from the job shop to the batch production to the assembly line, are generally minimum somewhere here, and they could stay minimum, but normally in this region they then do tend to rise a little. The rise of the manufacturing cost per unit in the commodity phase could be due to a variety of factors. You could look at them and see, but typically again here the costs here are relatively low, and generally the minimum cost would occur somewhere here, the cost per unit. So, the lesson is that as a company's products, market requirements, competition change, these are major things for the company. Products keep changing, market requirements keep changing, competition keep changing, so must the equipment, procedures and human resources. This is kind of a fact that emerges from the product process matrix, and the product process matrix helps primarily to understand why and how companies change their production operations as they tend to grow. So, there is an intimate link between product and processes, and as products mature, the processes that you adopt to make them also need to change. Let us now spend some time on talking about services and service processes. This world is increasingly becoming a place where services are more important. More and more people in this country and in the world are earning their livelihood through services rather than through manufacturing or through other areas now. So, in the design of services, what are the key features and how is it that we talk about designing? So, since we are talking about designing of both products as well as services. So, service design is very similar to product design, there is not much difference, but
there are certain differences. The differences are that certain services may not require, for instance, if you are talking about developing a service, you are talking about say hospital services, you can talk about postal services, you can talk about setting up an insurance company or something like that, or a banking system. These are all examples of service systems, right. So, certain services may not require engineering, it is obvious. If you are talking about a bank, you are not dealing with heavy machinery, but yes, you are dealing with automated teller machines and you are dealing with various other kinds of equipment, but they might not require engineering in the same sense as, for instance, you may need while setting up a refinery. Okay. It might not require testing in the usual sense, it might not require components analysis, it might not require prototype building of the product. You see, one of the things that is done in a product is that you build a prototype by using a rapid prototyping machine or otherwise of the product before you launch it, but for a service you might not have to do that. Another feature of services is that in service design, process technology involves different considerations. Why? Primarily because clients and customers are present in the conversion process. This is a significant difference between service design and the conventional factories. If you are designing a hospital, the customer will be a client in the whole process, and in fact he will go through the entire process. He will have to go for registration, he will then have to go to the appropriate doctor, he will have to go for medical diagnostics, then he will have to go to the doctor for prescriptions and so on. So, he actually flows through the system very much like the components that flow through a manufacturing process. Unlike, say, take a factory again like Maruti Udyog, they are making cars. The cars can frequently go through the, but the person who is going to buy the car never even sees the factory. Whereas in a hospital, the customer is very much a part of the process. So, the same is true in banking, the same is true in postal services, that the clients and customers are present in the conversion process. Therefore, the implications are that you have to take care of that you are dealing with people, and services have to be designed appropriately for these people. Services vary in the amount of customer contact, that is one thing, and also in the intensiveness of labor versus capital. I mean, services can be how many customers are actually interacting through the service, that is one thing, and then of course the intensiveness of whether you are using labor or capital primarily for doing this. We can try to summarize this information about service processes by looking at capital intensive versus labor intensive factories. I mean, you can say services, we are talking about services, and low customer contact versus high customer contact. So, we can have a grid of 4 essential classifications, and we can therefore look at service processes as of 4 types, and these 4 types can be called quasi manufacturing, very similar to manufacturing, customer shop services, this is second variety, mass services, this is the third variety, and the professional services, which is the fourth variety. And therefore, let us see what would be the differences in designing these kinds of services and what would be the kinds of situations in which they would be relevant. So, when you are talking about quasi manufacturing, you are essentially talking about something which is capital intensive and something where there is low customer contact, relatively low customer contact,
And so this thing is something like manufacturing, but quasi manufacturing, and examples are typically postal services or even banking services, which are very similar to postal services, automated area housing. These are typical examples where you could design services based on something like manufacturing. In that sense, you can look at a postal service design or a banking service design, which will be essentially capital intensive, let us say, and fewer customers, and you can design the process in terms of whatever objectives you are looking at. On the other hand, what do we mean by a situation where there is high customer contact? Customer shop services are essentially capital intensive and they have high customer contact. High customer contact means typically when you are talking of, for instance, things like medical treatment, there is a high contact, isn't it? The customer has to be present for each test that he has to undergo. So if you are talking about medical services like Max Care or some other care, they have to give medical treatment which is involving a high customer contact, and the kind of equipment and other things involved are pretty expensive. So here is an example. Similarly, charter travel is another example of a service where the customer has to be given high contact. He has to be, if there is a tourist airline or a tourist agency which takes you on a chartered trip to maybe Singapore and brings you back and so on. So it has to constantly keep on interacting with you because you are involved there, and you have a high customer contact and normally capital intensive kind of a thing. Now let us look at service processes which are essentially labor intensive. Labor intensive but low customer contact. It might come as a surprise to most of us that teaching is put in this category where you have labor intensive. See, lecturing, for instance, I am lecturing to you, it is a labor intensive process, isn't it? I am not using any machines or anything. It is a labor intensive process, and I am teaching a set of 50 or 60 students at one time, and it is a mass service in that sense, right? It is teaching, it is labor intensive, and there is low customer contact in this particular case. So do you agree with this classification or not? Why? Why don't you agree with this classification?
Because sir, teaching should have a high customer contact, so I would prefer moving it one step.
Okay. In fact, the distinction has been made here between teaching and tutoring. Tutoring is an activity which requires high customer contact. So when we talk about tutorials, we have to interact with you. We have to talk about, there is more of there is high customer contact, and it is also a labor intensive thing. So you can say the aspect of tutorials and practicals or tutors and so on, that process is here, right? So I think that takes care of it. Whereas during the process of teaching via a lecture, it is an impersonal process because it is a one-way process generally. There can be questions, there is a limited interaction, but it is essentially a process where there is low customer contact to some extent because I keep talking. So that is the reason. Are you satisfied, Eric? Not really? Okay, we will talk about it later. So this is teaching, and then similarly live entertainment. If somebody gives a live show on say Lata Mangeshkar comes and gives spends a Lata Mangeshkar night in your rendezvous, what is going to happen? It is a live entertainment. Essentially it is like lecturing. She just gives the performance. There is very little customer contact, so it falls in this category. Similarly, they say a cafeteria, for instance, is essentially something here. There is low customer contact, so you have this. Whereas, so these are called mass services. Mass services are those which are essentially labor intensive, but you are using low customer contact. On the contrary, if you use high customer contact, these services come under the category of professional services, where like legal counseling, if a lawyer has to take up a case of well, there are so many criminals, he can take up the case of anyone, and if he takes up this case, he has to understand the case very well, understand everything. So legal counseling would involve a high degree of customer contact. Similarly, medical diagnosis involves a high degree of customer contact, because the doctor has to prepare your medical history, listen to you, talk about everything. So it's a lie. Similarly, tutoring is if I have to teach you something, I give you a problem, you do it, you bring it back to me, and then I tell you do this. So that is tutoring, where there is high customer contact. Essentially what you find is that for this entire stage, generally the process technology is rigid, and for this stage the process technology has to be more flexible. Whenever you have dealing with high customer contact, your technologies that you adopt have to be more flexible to meet the requirements of different customers, whereas here you can afford to be little more rigid. So this matrix actually gives us an idea of different types of service processes and how exactly they can be designed. Automation is an interesting part of everything. In fact, we can keep on automating the various processes that are there. Remember, on one side we are talking about rigid processes, on the other side we are talking about flexible processes. So we have to accommodate both. So different kinds of things have evolved, right? When you are talking about automated banking, for instance, you have many of the rigid processes going on, right? You use your card in an ATM machine and automatically the money would come out, right? So that kind of an situation is actually an example of automated banking, where you have used technology and automation for solving these problems. An electronic grocery scanner, if you go to any shopping mall, for instance, all items have their cost and other information on barcodes written on each item. It can be picked up very easily through a barcode reader, and you can very easily have billing, inventory and all other related information very quickly as a consequence of these kinds of grocery scanners. So that's another example of an automation. Then we can talk about office automation. So office automation in the context of the modern office would be the use of PCs, the use of various software like word processing software, spreadsheets that are used to make things simple and try to help us generate knowledge from information. That's the basic idea of office automation. Of course, apart from this, there could be other facilities that we have, like teleconferencing, which is again office automation, which would help us to have interactive dialogues with somebody else at a different location. So one-to-one personal talk can be made available through these. So all these things, the point is that in various categories you can use different kinds of automation depending upon the situation. Let's now talk about the choice of the appropriate process. When we talk about the choice of the process, what are we essentially talking about? We are talking about choice which specifies, for instance, that different processes have different features in terms of their costs. So we can talk about a fixed cost and a variable cost.
For instance, at the initial stages you might want to just buy items directly, so there is no fixed cost, and you have something like this. For batch production you might have to set up a small facility and the unit variable cost will come down, or you might set up an assembly line at a much higher cost, which is the fixed cost, and then you have a situation like this. So this diagram simply shows that the job production, batch production and the assembly line would obviously be relevant only in certain ranges of production volume depending upon the break-even points, and therefore it is an important economic decision to determine which process you have to take. You have to be aware of not only the options but also the various types of volumes that you are dealing with. So in that sense, the choice of the process itself is actually an economic decision, and it's important. Since we are talking about process design and talking about the various process features, although we have already tried to mention some of the basic features of various processes, nevertheless it's worthwhile to look at the various important processes which occur in real life and see what are their features. For instance, if you talk, the first kind of feature is a project, which is generally an ad hoc thing. If you want to make something once, either on an ad hoc basis or you are doing something which you have to do not on an ad hoc basis but on a continuing basis, but you are doing it for the first time, then what has to be done is basically you have to identify what you want to do. From your objective, you have to identify the various tasks that you have to perform. Once you have identified these tasks, you have to plan and execute these tasks, and this entire thing is generally a one-time activity, remember that. So it's not repeated again and again. You set it up for one situation and then do it. On a job shop, what happens is you are using general purpose equipment. So on general purpose equipment we produce a variety of jobs, and each job chooses its route. So first job goes from one machine to another machine and keeps on going around in the job shop. The second job might select its own route depending upon its requirements and then go through the job. So this is typically what happens in a job shop, and these features mean that there is complicated or very difficult kind of flow patterns which emerge in the job shop. However, what's the advantage? The major advantage is that you get a lot of variety. You can produce variety, but this kind of a thing will happen. We then talk about various process features in terms of batch production. So what is batch production? It's like a typical job shop, when volumes become larger, could graduate to a batch production system. What would happen? A batch of similar parts would be produced by following a sequence of machines, and there would be savings from common setups. That's the typical advantage of batch production. So now you are producing, say, maybe 50 of these parts, then the next batch is 200, then 50 again, then 500, whatever it is, and you have therefore variety, but normally the variety here is limited as compared to a job shop. And finally, what happens in an assembly line? In an assembly line, you have one product produced in large numbers by processing on sequential workstations. And then first it is processed on one, then it goes to the next, then it goes to the next, and so on. And the obvious advantage of this is that the flows are very smooth and the volumes can be large. The production times are reduced. Why are production times reduced here? Not because operation times are reduced in any way. If you even produce these jobs in a process layout, the times would be there. So I take 2 minutes to produce this, 3 minutes to produce this, the total time will be the sum of these times. But what actually is saved here is that there is very little transfer of material from one department to the other, which takes a lot of time otherwise. So here you are on one operation, you go to the next machine which is immediately waiting, so setups and waiting times are reduced, as a consequence, this becomes a much faster process. In continuous production, examples like chemical plants and refineries, the product flows continuously with characteristics governed by environmental and control conditions such as temperature, humidity, chemical composition, catalyst, etc. So these are the things that you control to control the quality and the speed at which the process is moving. Finally, let's try to summarize what we have tried to talk about today. I think the first important lesson for us was that the product undergoes varying requirements during its life cycle. We saw the product life cycle and we saw that there were requirements which varied as the product went through these life cycles. Then we saw that different processes serve different needs, and typically as the product matures, different processes are required to capture those needs. So the product process matrix which we talked about was capturing this relationship between the product and the process essentially. Then we looked at the process life cycle, which talks about how processes mature. That means the nature of the process keeps changing depending upon how products have grown. We finally looked at the service matrix for categories of service, and service matrix meaning thereby that we had different kinds of service depending upon whether it is labor intensive or whether it is capital intensive, and then depending upon the element of customer contact. So we could divide services into 4 categories and tend to use this whole thing. Finally, we had a look at some of the features of different processing modes like projects, job production, batch production, assembly lines, and continuous production. And I think we must we emphasize the point that the choice of the process is essentially an optimal decision based on economics. So depending upon the situation and the context, you have to choose an appropriate process. I think apart from this, one of the important things we saw in this particular lecture was how product, process, and manufacturing decisions were interlinked, and we did look at some of the common charts and information sources for compiling this information and for talking about this, like assembly charts, route sheets, and operation process sheets, because these would be the situations, these will be things that you will have to consult while talking about or gathering information pertaining to the process. So I think in the next lecture we will talk about another major strategic decision about products, that is the choice or the setting up of the plant location or the facility location, which is a major strategic decision after you have designed the products and the services, which is the next stage of the life cycle of a production system. Thank you.